Okay, so let's continue lesson 1.1 from Math 0314. So last time we were working through this and I ran out of time, so I'm just going to start over again. Again, here what we want to do is we want to make sure we distribute. Watch yourself in the back here with the negative, this is technically negative 1, so we get negative 3x plus 12 plus 2 equals 7 minus x minus 1. Again, I want to combine like terms. When I try to combine like terms, before I start moving things to other sides, I want to see if I can consolidate or put together like terms on the side. So let's look at the left-hand side. We got 12 and 2. Both of those are numbers. So we can put those together. So I have negative 3x plus 14. And on the other side, we have 7 minus 1, which is 6. So even though the negative x is between the 7 and the negative 1, that doesn't deter us from putting 7 and negative 1 together. Okay, next up, we want to put like terms together. So I'm going to go ahead and I like to always put the variable, make the variable positive. So that means I would add 3x, right? And it'll give me 14 equals 6 plus 2x. Be careful with the positive negative signs. And then I'm going to move the 6 over. We have 8 equals 2x. And then to finish it off, I'm just going to divide by 2. And x is 4. So these problems are going to get longer and longer, but the approach is still the same. We want to distribute out. You want to combine like terms on each side. And then you want to combine like terms by putting all your variables on one side and all your numbers on the other, and then you'll end up doing some sort of division, and that'll give you the answer. Okay, so if you haven't done so already, pause the video, try number 14. Okay, so I'm going to assume that you've already done that, and what shall I do here? It's pretty much the same as the previous. We're just going to start off by distributing. I do want you to note that when I look at this question, I am seeing if there's any shortcut. So I'm seeing 4, I'm seeing 6, I'm seeing 6. And this is the leading coefficient here is 1. And I'm looking to see if maybe I can do some slick move to make the problem a little easier, to make the number smaller. But there's really nothing we can do. I want you to keep that in mind, though, because there may be something coming up that we might be able to do something like that, too. So, but here, straightforward, 4 times 2 is 8, so 8x, 4 times 2 is 8, and then we'll distribute again, negative 6x plus 6, watch that, negative becomes a positive, equals 6 minus x. Again, hopefully it's starting to sound like a broken record here. I want to put things that are alike together. So I look at the left-hand side, and this is an interesting case because I have 8x and negative 6x, don't forget the sign. So I'm going to put those together. But we also have 8 and 6, so I'm going to put those together and get 14. On the other side, I have 6 minus x. Those are not like terms, so I have to leave them as such. And again, I'm going to put my x's together first. So I'm going to add x to both sides because I want to keep my x's positive. I like to always try to keep my x positive. And then to finish it off, I'm going to subtract 14. So now I'm going to put my numbers together, and I get 3x equals negative 8. And to finish it off, divide through by 3. X is equal to negative 8 over 3. Want to stress that it's okay if the answer comes out to be a fraction. So, more of the same. Hopefully the past two problems have not been that tough. We're starting to see a little redundancy. On this, okay, so here what we want to do, well, what you want to do is first pause the video and attempt the problem on your own, okay? Let's say that you've done that. Now, what I'm looking at and what I always want to do is to try to make the problem as easy as possible to attack. So, this question is trying to stress the fact that you always want to start with your innermost parentheses. I'm saying this with air quotes because these are not technically parentheses, right? These are brackets. But you always want to start with the innermost of the function, right? or of the, there's not really a function, of the expression on the left side or of the right side. So what I'm actually going to tell you to do is a little slick move here. You don't have to do this if you don't like it, but I'm going to divide both sides by 2. And the reason I'm dividing both sides by 2 is that just becomes -2. So I'm looking at a smaller problem. If you don't like that, you can tackle it. I can drop the parentheses here because it's just 6 minus 5y. If you don't like that, you can just take on the inside initially. But I like doing things like that. I want to expose you to something like that for the simple fact that it makes the problem easier because the numbers are getting smaller. Now you might think to yourself, Mr. Anderson, come on, man, look at that. That's 2. Like, who cares? It's not really that big of a deal. It's not here, but it could become a deal. Big deal. Okay, so from here I'm going to distribute. Be careful again. You're distributing -3, right? So we have -2y minus 3y plus 15 equals 6 minus 5y. Okay? Just like when we had regular equations, the previous problems, I always want to try to consolidate if I can. So because I have y and -3y, I can put those two together. So -2y plus 15. Keep the game going. I've kind of run out of options here, so I'll just distribute the -2. So I'll get 4y, note negative times negative is a positive, and then -30 because negative times a positive is a negative. I have not done anything to the other side. Okay, so now what I'm going to do is, again, put the stuff that's alike together. By the way, as you watch these videos, if you feel like you are at a point that you can take over and you can solve the problem on your own, please do so. You don't have to, again, there's no reason to sit here and just listen to me if you know what you're doing. It's far better for you to work it out and compare your work to my work than it ever is to sit here and watch. But if you need to watch because you're not grasping something, that's perfectly fine as well. To finish this off, again, this means I'm multiplying, so I'm going to divide. Whenever you see a number and a letter next to each other, that means that you are multiplying. And there we have it. Y is 4. Okay, let's move on. Alright, so on this one, you may be tempted to be like, well, Mr. Anderson, you divided through by... let's go back to this one. You divided through by 2 here, so why can't I go through and divide through by 3, right? Well, you don't want to do that here because 3 doesn't go into 4, or 4 doesn't go into 3. So that isn't going to be the best move. So, go ahead. It looks like so much fun. I kind of want to just start attacking these problems without giving you a chance to do so. So why don't you go ahead, try the problem, and then once you've given it a go, press play, and let's see if our results match. Okay, so I'm going to assume that you've given it a go. Again, what I'm going to start off doing is I'm going to distribute. And the one on the left I'm going to distribute with the innermost, right? So we're here. Here we're just going to simple distribution. Watch the signs because that's a common mistake. Okay. Before I start distributing again, I want to see if there's some like terms. On the left-hand side, we got those together. We'll put them together. And then I'm going to distribute once more. I feel like you should be getting some sort of rhythm here with this. Okay, I'm going to put the variables together, so I'm going to subtract 4p. Again, I'm subtracting 4p, if you're curious, because I want to keep it positive. And then I'll add 12. And something interesting happens here. We get 5p equals 0. Now, we haven't seen this situation, but it's fine. We'll just continue the process. So I'm going to divide through by 5 because I want to get p by itself. And we have 0 divided by 5. And I want to stress here, you can use a calculator, but I want to stress here that what is this actually saying? So if you recall from last semester, this is you've cut the pizza into 5 slices. So this is what you've cut the pizza into, right? This is how many slices you are taking to eat. So if I cut the pizza into 5 slices, but I take 0 slices, how much pizza have I had? I've had 0 pizza. Okay? If it was the other way around, if it was 5 over 0, this would mean I'm cutting my pizza into 0 slices and I'm eating 5. Which at this point, I hope is telling you that I'm not making much sense, right? And when that happens, again, a nice little way of remembering this is when 0 is under, it's undefined. It's undefined. So 0 is under, it's undefined. Okay. All right. Now we're going to the part that many of y'all are like, I don't like this. Okay, so if you haven't already, go ahead, try to solve the problem, and then we'll talk about it. So, pause the video now, see if you can figure out how to do this. Okay. All right. I'm going to assume that you've tried the problem, and hopefully you remember, because we've talked about these before, if there's one rule that you take from your experience of taking this course, I hope it's the fact that you want to get rid of fractions as soon as possible. So I want to multiply by a number that's going to get rid of 4, 3, and 2. So the easiest way to do this is just to take the biggest of those numbers. So ask yourself, what's the biggest, 2, 3, or 4? Hopefully you said 4. And ask yourself, are all these numbers divisible by 4? Well, 4 is clearly divisible by 4. But 4 divided by 3 isn't going to work. So we'll take the next multiple of 4, which is 8, and see if it works. Well, 8 divided by 4 is, of course, going to work, but 8 divided by 3 is not. So we'll take the next multiple of 4, which is, we did 8, we're down to 12. So notice I'm doing 4 times 1, 4 times 2, and now we're doing 4 times 3, which is 12. Now that will work for everything, because 12 divided by 4 will work, 12 divided by 3 will work, and 12 divided by 2 will work. And when I say work, it will end up giving me an integer. So I'm going to multiply by 12. And what this means, let's see if I can fit all of this in here, is I'm going to multiply every term, not just the fractions, every term by 12. Okay? Maybe build some consistency here. Okay? Notice also in the back here, 1/2 times w minus 4 is a term. Remember, last semester we defined a term as the stuff, I'm using air quotes here, between plus, minus, or equals. Okay? So all of this is grouped together. Okay? So I multiply through by 12. And why would we do this? Well, because 12 divided by 4 is 3. 12 divided by 3 is 4. And 12 divided by 2 is 6. I've eliminated all the fractions. Okay? What I really did, if you want to use technical jargon, what I did is I multiplied by the LCM, the least common multiple. But you don't need to know these names. What you need to know is the process. So, and more important than the process, is what did I really do, right? I wanted to get rid of the fractions, so I had to multiply by a number that would get rid of all the fractions. So I had to find the most common number to multiply through by. If you struggle to find the LCM, the way I told you to find the LCM, I think, is the easiest way. There are multiple ways to find the LCM. Again, the way I told you is take the largest number, 4, and just keep listing multiples until you find one that works. So we did 4 times 1, 4 times 2, and then 4 times 3 ended up working. Okay. Another way to do this, it's a little, your numbers are going to get bigger, but it will always work, is to just multiply by 4 times 3 times 2. So notice 4 times 3 times 2 is going to give me 24, which is twice 12, but it still would work. And what would it do to all my numbers in the purple line? It would double those numbers because it's twice as much, right? So it will give you bigger numbers, but it'll still work. So if you're struggling, you can simply just multiply by all the denominators, and that will work. Okay? All right. Now let's take this from here. Hopefully you've paused the video and you've tried this on your own, because at this point everyone should be able to do these on your own. But let's go ahead and try them together. So on the left-hand side, I'm going to go ahead and put 3 and 4 together. Remember, what we always want to do is put combine like terms before we start tackling things. On the other side, on the right side, I'm going to go ahead and distribute. If you have no idea what to do, always just distribute. It's always a nice first move. Okay, I'm going to subtract 6w because I want to put, I always try to keep my variable positive. It's the one I go for first. And then I'm going to add 12 to both sides because I want to get my variable by itself. And I get my answer, w is equal to negative 12. So once you get rid of the fractions, the problem is not that bad. So if you haven't done so already, pause the video, try the next one. And I'm going to assume that you've paused the video and you've tried this on your own, and we're going to figure out what we're going to multiply by. So we're going to multiply through by 12 here again. I'm a little disappointed they use the same number, but 12 will get rid of 4, 2, and 3. Hopefully you caught on to that. This step I'm writing here, where I rewrite 12 in front of everything, you don't have to do it. I used to not really do it as my first step. You just do it in my head. But I'll tell you what, there's a value in visualizing what you're doing. So I'm a big proponent, especially when you start something or if something is for a real grade, to not take shortcuts, because when you start taking shortcuts, issues start to arise, right? So in terms of something like this, I would not be taking any shortcuts. Okay, so 12 divided by 4 is 3, so I'm left, notice 3 times 3a. 12 divided by 2 is 6, so I'm left with 6 times 1. 12 divided by 3 is 4, so I'm left with 4 times 2a. And 12 divided by 3 is 4, so I'm left with 4 times 1. And then I'll spend a line rewriting this so that it's a little cleaner. So 9a plus 6 equals 8a plus 4. So I'm just multiplying out the values. By the way, why do I multiply through by the values as opposed to, say, try adding things together? And this is a question that I asked you in the previous course. Hopefully you have the answer. PEMDAS, right? You got to multiply before you add and subtract. Okay. But now I'm in a situation where all I'm left to do is add and subtract. I'm going to subtract 8a to the other side because I want to put things that are alike together. I don't want to use that color. So we'll subtract 8a. And then I will subtract 6. And a is negative 2. There's my answer. So, I hope that there's a rhythm that you're developing with these, and as they get scarier and scarier looking, you realize, hey, they're really not. So, go ahead, if you haven't done so, go ahead, try to do number 19. It's really just more of the same. So, pause the video now and try it. And I hope you've paused the video and you've tried it, because I'm about to go through and do it with you. Okay, so I'm going to multiply through by the number that's going to get rid of 5, 2, and 10. Here, I hope you notice that if you took 10, it would work for both of them, right? Because 5 times 2 is 10. So I'm going to distribute 10 to everything. I usually actually like to draw an arrow. This right here is the one everybody forgets about, so it has to go into everything. So it's 2 parentheses x minus 2 minus 10 parentheses x x minus 4 over 2. No, this doesn't have parentheses, but you have to treat it as if it does. Equals 10 times 2, that's the interesting one, plus 10 x over 10. Okay, so we went ahead and multiply through by 10. These will divide out, we'll get 2, so we're left with 2 times the quantity x minus 2. Right here, these will divide out, and we'll get 5. So negative 5x minus 4, 20. Here, the nice thing is the 10s just cancel out, so I'm left with just x plus 4. And I wrote it in parentheses because this is in parentheses, but the truth is, and I might as well just do it right now, I don't need to put it in parentheses. A little ambitious with that erasing there. Okay? And take it from here. So hopefully you have an intuition here and you realize, hey, what I want to do now is distribute. Hey, what do I want to do now? I want to distribute. So I'm left with 2x minus 4 minus 5x plus 20 equals 20 plus x plus 4. Now you can, from here we can again consolidate. We can look at the left side and put things together, look at the right side and put things together. I do want you to note, and it's perfectly fine if you want to do that, please do so and just compare your results to mine. But one nice way of approaching this is because I have 20 here, and this is technically a plus 20, these are going to, we can just cancel them out, right? Or say we subtract both sides by 20, they would just go away. So if you see something like that, that's perfectly fine to do that. If you didn't like that, you're like, Mr. Anderson, I just wanted to do 20 minus 4 is 16, and I'm happy with that, that's fine as well. But I want to expose you to shortcuts of this nature because they really do make your life easier. And easier means you're less likely to make silly mistakes. Okay, so in any case, what do I do from here? Well, I'm going to see if I can put terms together on the left side. So I have 2x minus 5x. Watch the sign. Negative 3x minus 4 equals x plus 4. And I'm going to move that 3x to the other side. So negative 4 equals 4x plus 4. And I'm not going to do this. I naturally want to do this, but I think it'll confuse y'all. But I could, if I wanted to divide, I could go through and divide through by 4. But let me just do the traditional way. So we're going to subtract 4 from both sides. And finish it off by dividing by 4. So x is equal to negative 2. Okay. Oh. Alright, so pause the video now and see if you can solve this one on your own. Okay, so let's take some action on this. So what are we going to multiply through by to get rid of 8, 4, and 2? So hopefully you said 8. So we have 8 times 1/8 minus green, sorry, 8 times x plus 3 over 4 equals to 8 times 3x minus 2 over 2. And these will kindly divide out. Here, 8 divided by 4 is 2, so I'm left with 2 times the quantity x plus 3. Yes, this has to be a quantity. These divide out and we're left with 4, so we're left with 4 times 3x minus 2. And then I'm going to distribute the negative 2 into all of these, so I'll get negative 2x minus 6, and here we have the 1, and here I'll distribute and I'll get 12x minus 8. And from here again, I'll just look to consolidate. So I have 1 and minus 6, so I can put those together and get negative 5. The other side I have 12x minus 8. Now I will move the 2x over because I want to keep it positive. Negative 5 equals 14x minus 8. And then I will move the 8 over and get 3 equals 14x. And to finish it off, we will, let's go with this, I already used this blue, let's go with purple. I already used purple, I guess gray. Divide through by 14. So 3 over 14 is x. And there's my answer. Alright, on to the next one. Okay, so give this a shot and pause the video. And when you're done, unpause it. Okay, so I'm going to assume that you've unpaused it and you've given this a shot. This is not as difficult as it seems. The key here, and my advice for you, is to convert this into, well, let me do it this way. We know that 0.6 is 0.60, so we see that there is 2 decimal places over, right? And these would be whole numbers, right? What I'm really trying to say is, if we rewrite it as such, as fractions, right, we can use our rule of multiplying through by a number 2, in this case 100, to get rid of all the fractions. And that works nicely. So what that basically does is gets rid of the hundreds at the bottom. We're left with 55x minus 60 equals 205x. So you essentially, if you can make it such that every number jumps the same number of decimal places, you can multiply by that number. So if I jump twice, then it would be 100. If I jump 3 times, it'd be 1,000, etc., etc. And that'll create an equation that'll make the denominators all equal, and then I can multiply through by that. But you don't have to do all that. You could just say, hey, I'm going to jump 2 places. I'm going to make sure everyone jumps 2 places, and now I have no more decimals. And then from here, it's pretty straightforward. We're going to put the x's together. I'm subtracting 55 because I want to keep this positive as long as possible. That's going to be what? 160. I lied, it's 150. And then I'm going to divide through by 150. And this is just going to be what? The zeros will cancel out. 6 and 15 are both divisible by 3. So 2 and 5, so it's negative 2/5. And there's my answer. Okay, so take a shot at 22. Okay, so hopefully everybody's taking a shot at 22, and what we want to realize is this one's nice because I just have to jump 1 spot for all of these, and I get 22x plus 5 equals 16x plus 2. Combine like terms, so put the 16x together. And that'll give me 6x plus 5 equals 2. Move the 5 over. Equals negative 3. And to finish it off, divide through by 6. X is equal to negative 1/2. Okay, on to the next one. Okay, actually, I'm going to stop here because I got about 1 minute left. And we will pick it up here. I got about 5 more problems to get through. So I will see you guys in the next video.